Hey, don't realize math industry, and we are gonna take a look at stoichiometry. So wait a minute, what is stoichiometry? Well, this is a chemistry-related video, and what stoichiometry is relating and making ratios of particles, atoms, and molecules. So what we're gonna learn about is understanding what this is and get to the introduction of it. So there is one question that we're going to ask is when we balance the equations like these, why do we balance them? Well, that's because it doesn't follow the law of conservation, which means matter cannot be destroyed or created. But what we're going to understand and demonstrate is how this happens. How do we get from hydrogen and oxygen to a completely different product? So that's what we're going to do, but instead, we're going to do it with beyblades. So let's get started. To understand stoichiometry, what we have to do is demonstrate with the beyblades and then understand how we can use this in real life. So when we understand this, there's usually a formula you gotta follow. Just like this formula, there's an actual formula to creating a beyblade. What it needs is an energy layer. This is where the beyblade hits. This is the fork disc. The fork disc where the beyblade gets its weight and inertia. And a performance tip. Depending on the beyblade type, it will act in different ways. When you combine them together, you are going to get a beyblade in 3 parts into 1. Let's let it rip to understand that we have, what's this? We have reactants and products. So we're going to explain how this whole stoichiometry thing works. So let's see. What happens if I have one energy layer, one fork disc, and one performance tip? When we do that, we will be able to get one beyblade right there. So it follows the formula energy layer plus fork disc plus performance type equals a beyblade. But what happens if we change it up a bit? What if we have 1, 2, 3 energy layers? If I add 1, 2 performance tips, and I add 1 fork disc, what will be our products? Well, what's going to happen is I'm going to move this energy layer right here. I'm going to move this performance tip right here. And I'm going to move this fork disc right here. And it's going to make a beyblade. But this is a problem. We have a performance tip and 2 energy layers. And here's what's the problem. We made one beyblade that concludes the formula right here. All the 3 parts. But we can't use these because we don't have the fragments and we don't have the parts in order to make another beyblade. We don't have any fork discs. If we did, then we would make these, but then we have this one left over. Let's see what happens next. What the main idea is, when you have all the fragments to any beyblade parts, then when you sort them out on the products page, the thing is, you gotta prioritize to make as many beyblades as you can. If you spread them all out, it doesn't follow the stoichiometry rules, And it also doesn't follow the laws of chemistry, because those things will form into one. Let's do one more example. So we're going to have 1, 2, 3, 4 energy layers. We are going to have 1, 2, and we're going to have 1, 2, 3 performance tips. This and this will make Beyblades. However, these are not. So you see how it all works? When you have the fragments prioritized to make a Beyblade. If not, they just become remainments. And that is what's going to happen when we get over to this problem right here. So let's say that we are going to have 3 hydrogens, and we're also going to have 4 oxygens. So we're going to say 1, 2, 3, because of hydrogen 2s. See, 1, 2, 3. And here's O's. 1, 2, 3, 4. And what's going to happen is on the product side, here's what's going to happen. If the formula for water is H2O, then what's going to happen is we have to count these. We're going to say 1, 2, 3. So we're going to say that there's going to be 3 H2Os, the whole molecule. But there is a little problem. We still have 1, 2, 3, 4, 5 fragments left over in oxygen. So we're going to put 5 fragments right here. Not going to work. Here's a challenge. What can we do instead of 3 and 2? How many H2 and O molecules will we need to make exactly 4 H2O molecules? Why don't we try saying instead of 3, 4, and instead of 4, 2. Here's what's going to happen. We're going to say 1, 2, 3, 4 hydrogens and 1, 2 oxygens. We're going to see those are oxygens and these are hydrogens. What's going to happen? We're going to have 1, 2, 3, 4. 4 H2O molecules, water, and we have no remainments. This was from the last problem. So the reason why we balance the equations and the reason why we're doing stoichiometry is not only is our next unit, but it helps us understand what those coefficients are used for. They help us balance it so we can follow the laws of conservation. Now these are going to have parts into these. Sometimes when you make these, you'll have remainments left over. And that's how we use Beyblades to understand stoichiometry. I hope this video has helped you understand stoichiometry. Thank you for watching Top Penalized Math Industry. Like and subscribe.